Hi, Year 10. So we're going to start today going over those questions that you did for me last week. A lot of your answers are really good. In fact, much better, especially for this page, than what I have written. I was quite lazy in my answers, but I'm going to go through them now. So if you get a pen in your hand ready to mark and fill in any corrections for me, do that now. Okay, so question 1, we had to just pick the right word. So the sun is luminous because it emits light. The light reflects off an object that is non-luminous into your eye so that you can see it. Most objects do not transmit light, they are opaque. Then question 2, again, not a perfect answer here. So explain why it is so dark at the bottom of the ocean even though water is transparent. So water probably, especially not seawater, especially, I didn't even mention this here, seawater wouldn't be transparent, it would be translucent, and if you remember, that means it allows some light through. But because the ocean is so deep, then translucent objects will absorb a little bit, but if you have more and more of that, then it's going to absorb more and more of the light. So by the time you get down to the bottom, all of the light has been absorbed by all the masses amount of the sea. So I put a very simplified answer here, so it's really deep, so the water absorbs all the light. But that, what I just said, is that expanded a little bit. Now for number 3, I just drew a diagram, but I'm going to talk through what you should have in your answer. So describe the journey that light takes from the sun to the eye when you're looking at a fish in a pond. So here's my sun, here's my fish, and here's my eye. So the sun emits light, it travels in a straight line or straight ray to the fish, and then it gets reflected off the fish and goes up towards your eye. Now, in a few weeks' time, we're going to see that there's something else going on here, especially for a fish underneath water, but for now, that's all we would put for that answer, okay? So over on to page 60, our answers were really good on this page, so I'll be able to fly through these. So light travels in straight lines. This explains how shadows are formed on sunny days, how images are formed in cameras, and why there are reflections in mirrors. You cannot see something unless you have a line of sight, and the light can travel from the object to your eye in a straight line. Light waves are one of the ways that energy from the sun reaches the earth. So this question here was very like the little experiment I got you to do last week. So a student has been learning about shadows and how they're formed. She sets up a torch pointing at a wall. She puts a ball halfway between the torch and the wall, measures the shadow, has a width of 20 centimeters, and then she moves things around, and we have to say what way she has moved things for this effect to have happened on the shadow. So for this one here, the shadows got bigger, and she's talking about what's happened. She's moved the torch closer to or away from the ball. Must have been closer to the ball for the shadow to get bigger. If you don't believe me in any of these, remember, get your torch out, or your phone, the torch on your phone out, shining at an object between you and the wall, and see what effect that has on the shadow. Whenever she moved the torch away from the ball, the shadow's going to get smaller. This time the shadow got smaller, so she must have moved the ball closer to the wall. Okay. Now, for part B here, I would accept either answer as long as you had explained it properly, which is why I didn't write it in. So would the shadow of the ball and the wall be sharp, or would the edges be fuzzy? And explain your answer. I reckon this is going to, your answer in this is going to depend on the light source you use in your experiment. If you got a really sharp image or shadow, then you have used a torch that has a really small light source. Whereas if you're using maybe like say the light in your room, that's going to give a see the way my hand there, the shadow, that's very blurry from the ceiling light. Because it's an extended light source, it's going to give a fuzzy edge. So it depends which type of light source you're using there, and that depends on what you have been doing at home. So if you said sharp, you would say because it was a point source of light, and if it was fuzzy, you would say it's because it was an extended source of light. Okay, question 3. Here is a diagram showing some people and some buildings. Which pairs of people can see each other? So I coloured in the buildings just to make it a little bit easier to see what was going on. A and C are going to be able to see each other. A and E aren't, because C's in the way. If E was like ever just slightly down, then C wouldn't be in the way. So the light, unless C is a transparent person, these two are not going to be able to see each other. A and B, there's a building in the way there, but B and C can see each other. E and D can see each other. And D, there's buildings in the way for everything else. And that's really the answer for B. So why can the other pairs of people not see each other? It's because there's stuff in the way and the light can't travel in straight lines from one to the other. Okay, so turn back to page 57. If you remember, we left out these two sets of questions last week, so we're going to go back and do them today. And the reason we left them out was just because I wanted to remind you about these equations, and I felt like it would have ended up being information overload last week. So this is a funny wee set of questions because it's combining your knowledge of light that we've learnt so far, as well as stuff that we did last year. So if you remember, because this is all about the speed of light, do you remember learning this last year? Speed equals distance divided by time. Now, I've shown the rearranged versions of this, so if I was you, I would be making a note of this at the top of this page. So if I take this equation and I multiply both sides by t, I'm going to get speed multiplied by time equals distance. So that's that version there. And then if I wanted to make time be the subject, say the question was asking me to calculate the time, if I divided both sides of this equation by speed, I would end up with time equals distance divided by speed. So make a wee note of these because you're going to use these in this question, or these questions. Okay, now this little section here gives you a lot of information which you're going to end up using throughout these questions. So you can see I've summarised it for myself here. So the speed of light is 300,000 kilometers per second. It takes light from the sun 8.5 minutes to reach the earth. That I've listed all these ones here because it can be quite hard to pick them out or pick the wrong one. So sun to the earth is 8.5 minutes. Light has to travel for 4 years to reach us from the nearest star. So nearest star to earth, 4 years. And 1.3 seconds for light to travel from the moon to the earth. So moon to earth, 1.3 seconds. And I've just listed those to make it easier for myself to find those times. Okay, the speed is the same, no matter if it's going from the sun to us or the moon to us or whatever. It's 300,000 kilometers per second. So a couple of little warnings here. Be very careful with units whenever you're doing your calculations. This is kilometers per second. So see the way this here is in minutes, you would need to change that into seconds to match up with this, and then you would get your distance in kilometers. This one's in seconds, this one's in years. Oh, have a think about how you would change that into seconds. I'm not going to tell you. I will next week, obviously, not now. So let's have a little look at these and we'll see if there's anything in particular that's really awkward. So question 1 and 2 are relatively straightforward, so drawn on light rays and things like that. 3 onwards is where you're going to be using your speed equals distance over time equation. So sound travels a kilometre every 3 seconds after the lightning flash. Oh, you could get away without using your speed equals distance over time equation for this one. If you count 12 seconds, how far away? I'll let you have a think about that. Okay, I think the rest of those are okay. Now, whenever I say they're okay, they're not really easy, but I want you to spend the time trying to figure out how to do them. Okay, and then these ones over the page are going to be speed equals distance over time, or maybe rearranged, but just be careful with the numbers. They might be really big numbers, so just be super careful with that and be very careful with your units. Okay, so nice wee short video today, and that's really because it will take you time, a good amount of time to do these questions, and I want you to give them your best shot. Okay, so next week we'll go over these answers and then we'll move on. Bye.